Then at the tower, there'll be a tower box. And in that tower box, we'll have the contactor, the switch gear to turn the motor on and off that's on that particular tower. And each unit on out, each tower will have its own switch box to tell the tower when to turn on and off. And all it's doing is sensing its position in the field. Each tower tries to keep up with the one outside of it. That's how a center pivot works. We turn on the machine, and we automatically start the end tower. The end tower starts moving. It gets so far ahead of the next tower, and the next tower says, whoa, I'm too far, I'm out of alignment. There's a deflection here. Once it gets to maybe a half a degree, it senses that deflection, maybe a full degree, and it starts up, and it starts moving, and it catches up. And then, because it runs the same speed as the end tower, but it doesn't have to go as far to make a complete revolution, it catches up and gets ahead. And so once it gets ahead, it says, whoops, I got too far ahead, I'll stop, let that end tower catch up, let the end tower get ahead. It says, whoops, the end tower's ahead too far, I got to get on going again. It starts up, it catches up, it gets ahead, it'll stop, the end tower, and so on. So you got this oscillating motion. The end tower's determining the speed that it's going. All the other towers simply keep in alignment with the end tower. And it's done by, in most cases, a cam and limit switches. So we have, this would be mounted right up on the tower, right here. There's the tower box. And then it'll have a bar going out to the next span. And it's linked up here. And as there's a deflection in that pipe, it changes the location of the arm on the cam. And it's turning this switch on and off. And you can hear it clicking. And you can see it right here, turning it on and off. And so as it senses its position, it's going to turn it on, turn it off, turn it on, turn off. As this gets ahead, it turns off. As it gets behind, it turns on. And so that's in every one of these tower boxes, you'll have a unit that looks like this. And what it's doing is it's turning on this little thing right here. The contactor closes its set of points. It's sending power then down to the motor. So it's a pretty slick little deal, just done by linkage. Simple linkage. Now what happens is if we get lots of elevation in the field, that linkage can get a little sensitive. If we get a lot of where the one tower might be climbing a hill, the other one's going down a hill, it skews the linkage a little bit. So sometimes it can be a little tricky setting these up on certain fields. Nice level ground, never a problem. And that would be the main thrust on the tower box itself. Now, Bob was mentioning, we also then have to hook from tower to span. And so there is a linkage then, a mechanical linkage of some variety. Some of them simply use an eye hook. Some of them use like a trailer hitch, external, outside on the top of the pipe. Some of them use a universal joint to hook up between the two towers, and there'll be a rubber boot of some variety, either strapped on or it could be inside of a cast aluminum coupler. But there will be some kind of a connection between the two towers that generally is some kind of a boot, rubber boot, so that you can have flex this way, up and down, and side to side. You'll be able to have a lot of flex, a 15-20 degree flex minimum for all the variation that you might occur at any given tower from one tower to the next span.